Bismillahirrahmanirrahim. Welcome to the world of mathematics, and the source person is Hammad Hussein. Today we are going to discuss chapter number 2, that is differentiation. Today our topic is exponential function. Exponential function. What is exponential function? A function f defined by f of x is equal to a raised to power x if a is greater than 0 and a is not equal to 1 and x must be any real number, then this function is called exponential function. Suppose that f of x is equal to a raised to power x. There are two conditions on this function. If first condition is a should be greater than 0 and a can't be equal to 1 and x is any real number, then this type of function is called exponential function. Now, what is natural exponential function? If we replace a is equal to e in this function, then f of x is equal to a raised to power x will become y, or f of x is equal to e raised to power x. If we replace a by e, we will get f of x is equal to e raised to power x, or y is equal to e raised to power x. Then this e raised to power x is called natural exponential function. Then e raised to power x is called natural exponential function. Exponential function is f of x is equal to a raised to power x or y is equal to a raised to power x. There are two conditions: a is greater than 0 and a is not equal to 1 and x is any real number, then this type of function is called exponential function. And if we replace a by e, we will get e raised to power x, then y is equal to, or f of x is equal to e raised to power x is called natural exponential function. Exponential function is f of x is equal to a raised to power x, and f of x is equal to e raised to power x is called natural exponential function. Now, if we see the graph of exponential function, suppose that f of x is equal to or y is equal to 3 raised to power x, then its graph shape is look like this. This is a graph of y is equal to e the a raised to 3 raised to power x, or f of x is equal to 3 raised to power x. Almost all the graph of exponential function look like this. And if we go toward the daily life, example of exponential function very common is smartphone uptake and sale. At first, only a few had smartphone. When then within only a few years, it seems that everybody has an iPhone or similar. The growth in smartphone usage has been an exponential function. Look at, suppose that in 2008 only 1.2, 1.7 million people use smartphone. Then 2009 it will become 3.8 million. 2010 is 8.8 million. 2011 is 18, and 2012 is 25.2 million people use smartphone. The graph of exponential function is the best example of this. A graph of exponential function is this type, and this is also the graph of the uses of the smartphone. So this is the our best example of exponential function in our daily life. Now, derivative of exponential function. D by dx of a raised to power x is a raised to power x natural log of a, and derivative of x, a raised to power x natural log of a. As we know that exponential function is a raised to power x, so derivative of a raised to power x means that a raised to power x natural log of a, and derivative of power. Here power is x, so d by dx of x, and derivative of x with respect to x is 1, so derivative of a raised to power x is a raised to power x natural log of a. And now what is the derivative of natural exponential function? That is e raised to power x, e raised to power x natural log of e d by dx of x e raised to power x. Why? Because natural log of e is equal to 1. Here e raised to power x is e raised to power x natural log of e, and derivative of power. Here power is x, so derivative of x with respect to x is 1. So e raised to power x natural log of e, and as we know that natural log of e is equal to 1, so derivative of d by dx of e raised to power x is e raised to power x. So derivative of a raised to power x is a raised to power x natural log of a, and derivative of e raised to power x is e raised to power x. Now we will move toward the proof of derivative of a raised to power x, that is a raised to power x natural log of a. D by dx of a raised to power x is a raised to power x natural log of a. Let y is equal to a raised to power x. We will solve it by the method of first principle ab initio or by definition. Replace y by y plus del y and x by x plus del x. Now take y to the right hand side. So del y is equal to a raised to power x plus del x minus y. And what is the value of y? Value of y is a raised to power x. So a raised to power x plus del x can be written as a raised to power x into a raised to power del x. Because why? Because if bases are same, then power will add, and if power is added, then we can write in form of same base. A raised to power x into a raised to power del x minus a raised to power x. We can take a raised to power x common. The remaining is a raised to power del x minus 1. The third step of by definition, first principle of ab initio method is divided by del x on both sides. When we divide del y, del x, so left hand side will become del y by del x, and right hand side is a raised to power x, a raised to power del x minus 1 over del x. The next step is applying the limit, and if we apply the limit to the left hand side, it will become dy by dx, and apply the limit to the right hand side, that is limit del x approaches to 0, a raised to power x, a raised to power del x minus 1 over del x. A raised to power x is constant, so constant out. The limit del x approaches to 0 apply on a raised to power del x minus 1 over del x. Limit del x approaches to 0, a raised to power x is equal to a raised to power. That's why a raised to power x come out of the limit. Now a raised to power x natural log of a. Using limit h approaches to 0, a raised to power h minus 1 over h is equal to log of a to base e, that is equal to natural log of a. So a raised to power x as it is, and this term is equal to natural log of a, and that is reference of theorem number 3, page number 23, chapter number 1. Limit h approaches to 0, a raised to power h minus 1 over h is equal to log of a to base e, and that can be written as natural log of a. That's why we can write limit del x approaches to 0, a raised to power del x minus 1 over del x is equal to natural log of a, which is our right hand side. Now we will move to exercise 2.6. The question number 1 is find f prime of x if f prime of x means that f dash of x means that first derivative of f of x. Our first part is f of x is equal to e raised to power del x under root x minus 1, e raised to power square root of x minus 1. First part, differentiate with respect to x means that d by dx of f of x is equal to d by dx of e raised to power x minus 1. Left hand side will become f prime of x, and right hand side is d by dx of e raised to power x square root of x minus 1. We know that derivative of e raised to power x is e raised to power x and derivative of power. Here x is square root of x minus 1 and power is square root of x minus 1. So e raised to power square root of x minus 1 d by dx of square root of x minus 1, e raised to power square root of x minus 1 as it is. Now derivative of square root of x minus 1, 1 is constant, so derivative of 1 is 0, and here we will use power rule. Power is 1 by 2, power is 1 by 2, so answer is 1 by 2 x raised to power minus 1 by 2, and this minus when goes to the denominator will become x raised to power plus 1 by 2, that can be written as square root of x. So our final answer is e raised to power square root of x minus 1 over 2 square root of x, which is our part number 1. Now second part is x cube e raised to power 1 by x. Here two functions multiply, so we will use product rule. First step is differentiate with respect to x on both sides. When we apply differentiate left hand side, it will become f prime of x and d by dx of x cube e raised to power 1 of 1 by x. Here two functions are multiplied, so we will use product rule. X cube as it is, derivative of e raised to power 1 by x plus e raised to power 1 by x as it is, derivative of x cube. Now x cube e raised to power 1 by x. E raised to power 1 by x it is derivative of 1 by x. Why? Because we know that the derivative of e raised to power x is e raised to power x and derivative of x. Here x is 1 by x. So we have to take derivative of 1 by x. And e raised to power x and derivative of x cube according to power rule is 3x square. Now d by dx of 1 over x can be written as d by dx of x raised to power minus 1. Applying power rule, it will become minus x raised to power minus 2. That can be written as minus 1 over x square. So d by dx of 1 over x will be equal to minus 1 over x square. So x cube e raised to power 1 by x, and this term is equal to minus 1 by x square. This x square cancel with the power of x cube, so remaining is only minus x e raised to power 1 by x plus e raised to power 1 by x 3x square. Now here we can take common e raised to power 1 by x, and x final answer is x e raised to power 1 by x 3x minus 1, which is our final answer of part number 2. Now, part number 4. F of x is e raised to power x divided by e raised to power minus x plus 1. F of x is equal to e raised to power x over e raised to power x minus 1. Here two functions in the form of quotient, so we will use quotient formula. First step is differentiate with respect to x. Left hand side will become f prime of x. Right hand side is d by dx of e raised to power x over e raised to power x minus x plus 1. So applying the quotient formula, that is denominator square, denominator as it is, derivative of numerator, minus derivative of denominator and numerator as it is. Denominator square, denominator as it is, derivative of numerator, minus numerator as it is, derivative of denominator. E raised to power minus x plus 1, derivative of e raised to power x is e raised to power x into derivative of x, that is 1. So e derivative of e raised to power x is e raised to power x minus e raised to power x as it is here. Derivative of e raised to power minus x is e raised to power minus x, and derivative of minus x is minus 1. Here 1 multiplies, so no need to write e raised to power x into 1, but here minus 1 multiplies, so it is compulsory to write e raised to power minus x into minus 1. Why? Because derivative of minus x is minus 1. And as you know that derivative of 1 is 0. So our required numerator is e raised to power x into e raised to power minus x plus 1 minus e raised to power x e raised to power x minus 1. This minus and minus will become plus, and we can take e raised to power x common. If we take e raised to power x common from the numerator, the remainings are e raised to power minus x plus 1 and plus e raised to power minus x. Why? Because minus into minus is plus. So e raised to power x into e raised to power minus x plus 1 plus e raised to power minus x. E raised to power minus x and into plus e raised to power minus x is 2 times e raised to power minus x plus 1 into e raised to power x over e raised to power minus x plus 1 whole square is our final answer. So this is our part number 4. Now We will move to question number 2. Find dy by dx if. Find dy by dx if. Part number 8 is y is equal to e raised to power minus 2x into sine 2x. Y is equal to e raised to power minus 2x into sine 2x. Here two functions. For one is exponential function and the second is trigonometric function. So we will apply product rule to find dy by dx. So differentiate with respect to x, we will get left hand side is equal to dy by dx and right hand side is d by dx of e raised to power minus 2x into sine of 2x. So we will use product rule, e raised to power minus 2x as it is, derivative of sine 2x plus sine 2x as it is, derivative of e raised to power minus 2x. E raised to power minus 2x. As we know that derivative of sine 2x is cos 2x and derivative of angle. Here angle is 2x, so derivative of 2x is 2. So derivative of sine 2x is cos 2x into 2 sine 2x as it is, and a derivative of e raised to power minus 2x is e raised to power minus 2x as it is, and derivative of power, here power is minus 2 to minus 2x, so derivative of minus 2x is minus 2. This minus and this plus will become minus, so and we can take 2 e raised to power minus 2x common, so our final answer is 2 e raised to power minus 2x cos 2x minus sine 2x. Cos 2x minus sine 2x our final answer. Now part number 10. Y is equal to x e raised to power sine x. One function is algebraic function and the other function is exponential function, and what is power is trigonometric power. So differentiate with respect to x. Left hand side will become dy by dx. Right hand side we will use product rule. X as it is, derivative of e raised to power sine x plus e raised to power sine x as it is, derivative of x. E raised to power x derivative means that e raised to power sine x derivative means that e raised to power sine x and derivative of sine x plus e raised to power sine x and derivative of x is 1. As we know that derivative of sine x is cos x, so x e raised to power sine x into cos x plus e raised to power sine x. X e raised to power sine x and derivative of sine x is cos x plus e raised to power sine x. Now we can take common e raised to power sine x, so remaining is e raised to power sine x into x cos x plus 1, which is our final answer. So this is our part number 10. Here we have two function, one is algebraic and other function is exponential function, but power is trigonometric ratio. So we will use product rule, x as it is, derivative of e raised to power sine x plus e raised to power sine x as it is, derivative of x. Derivative e raised to power sine x is e raised to power sine x, derivative of sine x and derivative of sine x is cos x, and derivative of x is 1 with respect to x. Now second last step is take e raised to power sine x common. We will get e raised to power sine x into x cos x plus 1. Now we will move to example number 1. Find dy by dx if y is equal to e raised to power x square plus 1. Find dy by dx if y is equal to e raised to power x square plus 1. Let u is equal to x square plus 1. So this will become y is equal to e raised to power u. Y is equal to e raised to power u. Here we have two equations but three variable. One is x, another is y, and third is u. So we will use chain rule. So y is equal to e raised to power u and du by, here x is an independent variable and u is dependent variable. So differentiate this equation with respect to x. We will get du by dx is equal to 2x. Why? Because derivative of x square is 2x and derivative of 1 is 0. So du by dx is equal to 2x. Now differentiate both sides of equation a with respect to x. Y is equal to e raised to power u. Means that d by dx of y is d by dx of e raised to power u, and d by d of e raised to power u into du by dx, or d by du of e raised to power u is e raised to power u, and derivative of power, here power is u, so du by dx. And what is the value of du by dx? The value of du by dx is 2x. So du by dx replaced by 2x, and e raised to power u is replaced by x square plus 1. So final answer of e raised to power x square plus 1 derivative is e raised to power x square plus 1 into 2x. Thank you, students. If you have any question, you can ask me anytime. Thank you and have a nice day.